All right, welcome back to Mr. P Helps with Algebra. This is Unit 3, Topic 1, Lesson number 4, titled After School Activities. So we're going to be doing two-way frequency tables. Now, you may have done one-way frequency tables with tally marks in the past, but this way we're going to do two-way, both horizontally and vertically, straight up and down. All right, so we're going to start off with a warm-up, which is going to be interpreting scatter plots. Maybe you have seen scatter plots, maybe you have not. So each point here represents one piece of data. It has an X value and a Y value. So each one of these represents one person with a shoe size and a height. Now, in this warm-up, we're basically looking at these two and we're comparing them and we're asking ourselves, hey, one of these does not make any sense. And which one of them does not make any sense? One of them has a correlation, one of them has no correlation. Now, this one right here has what we call a positive correlation because the correlation as one increases, the other one also increases. Negative correlation is when one label increases, the other one decreases. Or more easily, this is a positive correlation because quite easily you can see that the slope, if you put a straight line through the middle of the data, is going up. Positive goes up, negative goes down. So think of just like slope when you're doing linear lines. Now, this one over here, if I was going to draw a straight line through the data, it would go straight across horizontally. That means that it has no correlation. Now, there's a good reason for that, because if you think about it, just because you were born on the 32nd of a month, or 31st, I guess I should use, 32nd wouldn't make any sense, 31st of a month does not have anything to do with how heavy you're going to be when you're born. I mean, the day you're born on has nothing to do. You can't just say that all babies born on the 1st of a month are all going to be underweight. That just makes no sense. What day you're born on has nothing to do with your weight. So this makes absolutely no sense. Now, there is a correlation here, and it's not a direct correlation. Direct meaning in a straight line. It's not in a direct straight line because just because you're tall doesn't mean you're going to have the biggest shoe size. Or just because you're short doesn't mean you can't have a slightly bigger shoe size than somebody who's slightly taller than you. So there is a correlation. Usually the taller you are, usually the bigger your shoes get. That is true, but it's not a direct relationship. So somebody who's the same height as you might have bigger feet than you. So you can't say it's going to be exactly the same. All right, now, getting to what we're doing within this lesson, which is two-way frequency tables. Remember I said they both go horizontally across? So you'll notice that in the soccer, there's a total here, which is adding up these two joint frequencies, gives you this marginal frequency. Now, think of the margins of a piece of paper. The margins of the paper are the outside edges. So the marginal frequencies are really just the totals. So it's when you add up all these numbers, you get 54. Dance, 46 plus 6 makes 52. Now, going straight down, you'll notice that vertically, we've also got totals. 40 plus 6 makes 46. Let's delete that. And 14 plus 46 makes 60. So you've got your vertical totals. That's your marginal frequency here. And then your horizontal totals, which would be your marginal frequency on this side. So that's the reason why we call it a two-way frequency table. Now, we'll get to relative frequency tables in the next video. But for right now, we just want to make sure we understand that they are going to add up in both directions. And what you'll notice that both of these totals both add up to 106. So your total here is the whole, and it's the whole amount of people that were surveyed in this. So the total amount of people between who chose soccer and dance is going to be the same amount of people surveyed as the total amount of boys and girls surveyed, because it's the same people that were surveyed. They just happen to be separated in two different ways, in two different categories. Both, boys and girls as one set of categories, and what they picked as the other way of separating them. Now, looking at this story, this is pretty easy. Two-way frequency table allows us to organize categorical data in two different ways and draw conclusions. Create a frequency table. Okay, there are 45 total students who like to read books. Total people who like to read books. So that's the very total. That goes right here. Next piece of data. Of those students, 12 of them like nonfiction. So that's going to go right here. Now, based upon what we know, what plus 12 makes 45, and that happens to be 33. If the pen would work properly. There we go. And the next sentence says, and the rest of them like fiction. Okay, we just did that. 4 girls like nonfiction. 4 girls like nonfiction. Okay. So if 4 girls like nonfiction, it was a total of 12 people who chose nonfiction, then that must mean that the amount of boys, okay, having some technical difficulties here, 12 minus the 4 must have been 8. All right, let's put that number in here. Come on, pen. There we go. All right, so 8 plus 4 makes 12, and then 20 boys like fiction. So that would go right here. Now, it was a grand total of 33 people, so 20 plus 13 would be 33. And now I can find out my totals, my marginal frequencies over here. 20 plus 8 makes 28. 13 plus 4 makes 17. And yes, 28 plus 17 does make 45. And this way also makes 45, true, because that's the way I made it work. Okay, so it works. Observational data. What does the data say to you? So what conclusion can you make? Well, it looks to me in this case that, well, there's more boys surveyed here, but I'm not really going to say. That's not really an overwhelming conclusion to this. So I'm looking for, I would say that 3 times more people chose fiction than nonfiction. Give or take. Now, it's not exactly 3. It's actually slightly less than 3. So I would say in the wording, it's almost 3 times many people chose fiction as nonfiction. That's definitely a major conclusion in this case. There were more boys than girls surveyed. So you could say that there was twice as many boys as girls surveyed. But in the end, that's not going to affect the results. But that is another way of looking at it. So I compared these two, and I compared these over here as well. All right, so there's your observational statements. Those are statements based upon what you noticed. So in this case, once again, I guess I got to talk about boys versus girls and then fiction versus nonfiction. 3 times many. That is the most important fact in this case. Or you can change that to a percentage, or you can change it to a ratio. However you want to give the data is fine. 35 7th graders and 41 8th graders completed a survey about the amount of time that they spent on homework. So 35 7th graders. So it looks like our 2 categories are going to be 7th graders and 8th graders. And there's 35 here, and there's 41 here, which means there's a grand total of 76 people surveyed. 50 students said that they spend more than 1 hour, okay, on homework. More than 1 hour, so that would be right here. So that's 50. And 50 plus 26 makes 76. So there's my total there. 12 8th graders said that they would spend less than an hour. Okay, 12 8th graders spend less than an hour. Okay, so that's 12 right here. All right, so now what plus 12 makes 26? And that would happen to be 14. What plus 12 makes 41? So let's see. 18 plus 12 will get me to 30. Okay, 28 plus 12 will give me 40. So it's got to be one more than that. It's got to be 29. Yep. And what plus 14 equals 35? That would be 21. All right, and we're done. Okay, so what conclusion can I make? Well, it looks like there's twice as many people spending more than 1 hour on homework than less than 1 hour. So that's a major comparison between these 2 pieces of data. It looks like we have an equal amount of people surveyed in 7th and 8th grade, so that's another conclusion. You could say 50, almost 2 out of every 3 people said that they had more than 1 hour of homework. So these are just things that you could write down here. Anything that statement. So you can actually look at your joint frequencies as well. If you want to compare these numbers right here, you can say there's about twice as many that chose this and twice as many here as well. All right, getting to the homework. So now there's 20 people in this class, and it looks like a student needed a score of 6 or better to pass the quiz. So how many people in first period passed the quiz? So all I'm going to do is sit here and just count how many got a 6 or better. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'm sure somebody's going to tell me I'm going to make a mistake here in the video. That's all right, just put it in the comment section. I'm pretty sure this was 20 people total, so that's 8 people that must have failed. 6, 1, 2, 3, 4, 5, 6, 7. 7 out of 15, so that must mean that this had to have been 8. Third period, I believe, is also 15. I counted it earlier to save a little bit of time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 people passed, which means only 3 people failed. Now I'm going to double check that one because that one's going to be easy. 1 failure there, another failure there, and another failure there. Yep, that one works. All right, so figure out the totals all the way across. So this is 30 plus 20 more makes 50 people surveyed. 12 plus 7 makes 19. 19 plus 12 makes 31, if I'm not mistaken. What did I just say? I said 19 plus 12. Yeah, 31. 8 plus 8 is 16, plus 3 more makes 19. If you add those together, you also get 50. Great. I believe that's it. 10 minutes. I made pretty good time, too. Please give it a like if it helped you learn something about two-way frequency tables. Next thing we'll do is relative frequency tables in the next video. Thanks again for watching. Have a great day.